Okay, so here's a video going over the rational expressions quiz in case you want to review for a retake or for a cumulative exam like the midterm. Rational expressions was fractional expressions, right? So we're talking about fractions. And the way that we do this is we essentially factor and cross out identical things. So what I'm going to do here for number one is I'm going to recognize that 18 and 21 are both divisible by 3. So this becomes 3 times 6. This becomes 3 times 7. There's 3 k's on top, so I'm going to break them up like this, and just a k squared on bottom. Another great thing I can do is cross out the 3's, cross out the k squareds, and I get 6k over 7. That's my final answer. The answer is D. Question 2. See if you can do what I just did. I mean, like, pause it and try the question. Okay, if you're watching it, I assume you've tried the question. And if not, shame on you. So what I'm going to do is 14 and 56 are both divisible by 7. So I'm going to change this into, I'll keep the negative out front. This will be 7 times 2. On the bottom will be 7 times 8. On the top I have m to the 4th, so I'm going to break it up like that. I have a single m on bottom, and cross these out, 7 and 7, m and m. My answer is going to be 2m cubed over 8. Wait, that's not right. 2 and 8 can still be simplified. So what I can do is 2 divided by 8 is also equal to 1 over 4. So I've got m third, the negative, over 4. Question 3. I have to factor this. It's pretty simple. These two have a GCF. So the x plus 5 stays by itself. Nothing changes. On the bottom, I can factor out a 7x, leaving me with x plus 5. Now the x plus 5's can cancel out, which leaves a 1 on the top. And my answer is C, 1 over 7x. You could always slow down the playback speed, by the way, if this is going too quick. Here, on the top, I have a GCF of 5m, leaving me with 5m minus 8. On bottom, I have 50m cubed. I would love to be able to cross out the 5, so I'm going to change it into 5 times 10. I'm going to break off an m, so it becomes mm squared. I can cross out a 5 and a 5, an m and an m, and that's it. My answer is D. Question 5. Now we're into multiplication. The great thing about multiplication is you can basically just act like it's one giant fraction. So here's the only thing I'm going to factor. This here. That can be factored. It can be factored because I can pull a 4a squared out of it, leaving me with a minus 4. You could mentally distribute back in to make sure that's right. I would recommend it. Since these two are equal, I've just replaced it. Let's see what I can cross out. 4a squared, 4a squared, and that's it. A minus 4 over a plus 7. The 1 is still here technically, but 1 times a minus 4 doesn't change anything. Question number 6. If you have division, remember that you are keeping, changing, and flipping, because we do not multiply, or rather we do not divide fractions. That's messy. So what we're going to do is we're going to keep, change, flip. 9x plus 9 over 8, we keep that the same. Change it to multiplication, and flip this. So I get x minus 7 over 9x minus 63. Now I recognize that this can be factored, so I'm going to change it. I'm going to factor out a 9, leaving me with x minus 7. That's awesome, because I can cross out this and this. This has been replaced, okay? On the top left, I also recognize that I can factor out a 9, leaving me with x plus 1. And now this has been replaced. So let's see all the awesome things we can cross out. X minus 7, x minus 7, 9, and 9. My final answer is going to be that. It's going to be x plus 1 over 8. Answer choice A. Question number 7 is also division. I'm going to make my life easy here. I'm going to do the same thing. Keep change, flip. So I keep the larger one the same, 2b minus 1 over 2b squared minus 17b plus 8. That's times now b minus 4 over 1. Now I know that I need to factor this. The only question is how. I can't divide them all by 2 because this is an odd number. So what I have to do to factor that is I have to go off onto my sidebar and do a little bit of scratch work. 2b squared minus 17b plus 8. Whenever we have a quadratic with a number on the front that we can't change, we can't do anything about, we can't get rid of it, what we have to do is we have to do a times c. So 2 times 8 is 16. I'm looking for factors of 16. So I'm thinking 16 times 1, 8 times 2, and 4 times 4. Now they need to be able to add to negative 17, so I think I'm going to have to do this. Negative 16, negative 1. The negative and negative will multiply to get me still a positive 16, but they'll add up to a negative 17. So split the middle term into negative 16b minus 1b. Bring down the other two terms. And now that I have 4 terms, I can factor this by grouping. I factor out a 2b in the first, leaving me with a b minus 8. On the right, I can factor out a negative 1, leaving me with b minus 8. So the factored version of this that I started with is going to be 2b minus 1, b minus 8. So those are equal. So since those are equal, I'm going to go back to my original, and I'm going to rewrite this as 2b minus 1, b minus 8, and now it's been replaced. Let's see what I can cross out. 2b minus 1 and 2b minus 1, and it looks like that's it. So b minus 8 times 1, well that's simple, that doesn't change anything. So I just get to get b minus 4 or b minus 8. And A is my answer. On to question 8 in the free response. Now we have to add. Question 8 is easy because they already have common denominators. In order to add, you need common denominators. So what I'm going to do, since they already have them, is I'm just going to smush them together. So this is equal to 4b plus 6b plus 10 over 4b minus 16. 4b plus 6b up here, that's going to be 10b plus 10 over 4b minus 16. I always need to make sure that I simplify, so let me factor. On the top, I can factor out a 10. On the bottom, I can factor out a 4. And this fraction over here, 10 over 4, those can both be divided by 2. 10 over 4 is also 5 over 2. So my eventual answer my final answer is going to be 5b plus 1 over 2b minus 4. Now you could have rewritten this as 5b plus 5 over 2b minus 8. That's fine too. Totally acceptable. That's still simple. There's nothing that I can do with these anyway, so. But either one of these is an acceptable answer for this question. If you didn't simplify, you lost 1 point. Question number 9. These do not have the same denominator, and I need to create them first. The easiest way to see what I need to do is to take anything that's factorable in the denominator and factor it first. So factor the denoms first when possible. So here's what I do. I say, alright, this can factor out of 2, leaving me with r minus 6. Now this has been replaced. Well, that works out really well because I recognize that all I have to do is put an r minus 6 here, and I have the same denominator. I need to do it on top as well to balance it out. I'm going to rewrite because I don't want to be super messy. So I have 3 r minus 6 over 2 r minus 6. Don't forget your parentheses. Minus r plus 6 over 2r minus 6. Since these have the same denominator, I can smush them, giving me 3r minus 6 minus r plus 6 all over the same denominator, which is 2r minus 6. Remember that when you are adding or subtracting, when you smush them together, they keep the identical denominator. What I need to do now, I think, in order to simplify some things, is probably distribute the 3 and distribute the negative. So I get 3r minus 18 minus r minus 6 over 2r minus 6. Combine some like terms on top. 3r minus r is 2r. And negative 18 minus 6 is minus 24 over 2r minus 6. I recognize that the top can be factored. I can factor it at 2, leaving me with r minus 12. On bottom I have 2 r minus 6, and cross out the 2's. My final answer is going to be r minus 12 over r minus 6. If you want to back up and watch that one again, it might be a good idea, just to make sure that you know what's going on. I'm going to move on to question number 10. Same deal. I want common denominators, and I don't have them yet. So I'm going to factor out anything that I can. Let's say I'm going to factor out a 3k. That leaves me with k plus 1. You can mentally distribute back in to make sure that's right. And now this has been replaced. Now on the left-hand side, I have a 3 and a 3. So I still need a few things. I need a k, I need a k plus 1. So let's do it like this. I need to do it on top as well. Let me rewrite because this is getting messy. The top here, 2k squared times k plus 1 over 3k k plus 1 plus k minus 6 over 3k k plus 1. Since they have the same denominator, I can do what I always do, which is smush them together. I get 2k squared k plus 1 plus k minus 6 all over 3k k plus 1. I'm going to distribute on top and hope that I can get some like terms, because otherwise I don't really know where the simplifying is coming from. I get 2k cubed plus 2k squared plus k minus 6 all over 3k k plus 1. The only thing that I can think at this point is maybe the top is grouping. That's what should be going through your head. This might be grouping because it has 4 terms. Let's check. Pull this off to the side and let's give it a shot. 2k cubed plus 2k squared plus k minus 6. Let's see. GCF for these. GCF for these. I can pull out a 2k squared, leaving me with k plus 1. On the right, all I can pull out is a positive 1, leaving me with k minus 6, and these are not the same. So it can't be factored by grouping. If it seems like we've hit a dead end, that's because we have. Not all the answers are guaranteed to be pretty. That's as simple as we're going to be able to get it. Okay? So that was the answer for question number 10. I hope that this has been helpful, and make sure that you study, rewrite the questions on some blank paper, try them yourself, and make sure that you can get them, because that retake is coming up.